Hello everyone, we are Team Jaseci AI. Our project is TinyLLama Fine-Tuning Project. In this project, we develop an auto-adaptive fine-tuning system for Jack by LLM using RPG game level generation as a test case. The system leverages large language model GPT-4 to generate structured game levels, automatically collects prompt response data, and continuously fine-tunes smaller local models like TinyLLama using LoRa. By integrating dataset generation, automated filtering, background training, and intelligent model switching, the system reduces API costs, latency, and external dependencies. It enables Jack by LLM to evolve into a self-improving, cost-efficient, and low-latency platform for structured generation tasks, ensuring high-quality outputs compared to large cloud-based models. To describe the code, I invite Dunya. Over to you, Dunya.
Thank you, Susangi. Let's work through the code implementation. First, dataset generator. This script creates maps for a simple 2D game. It begins with an empty map and then adds players, enemies, and obstacles. How many of these appear and how tricky they are depends on the chosen difficulty level. In the end, all maps are saved in a JSON file. Next, we have dataset tokenizer. This is Python script improves a TinyLLama model for creating game maps. It starts by loading tokenizer to process text and ready-made map datasets. The script then converts text maps into numbers that model can read. Lastly, it saved and converted dataset to get it ready for training. Next, we have configure files. This code is a settings file for a game, serving as the main place to store all important game options. It sets fixed values for the screen size, how game objects are drawn in players, the speed of the players and enemies, and the colors used. This setup allows for easy changes to the game's behavior without touching the core program. Next, we have dataset collector. This script keeps making and saving new game maps. It works on its own, choosing a random difficulty level between 1 to 7. Then it builds a map and saves it as a sample, creating a big collection of maps for later use, like teaching a model. Moving on, let's discuss how the preprocessor Python script works. This script prepares data for training a language model. It loads game map data from a JSON file, formats into a question and answer structure, converts text into numbers with fixed lengths, and saves the data while maintaining a temporary file for modeling training. Next, we have map filter, which creates functions to check game maps. It makes sure a map can be played, count enemies and obstacles, and confirms the map's structure is right. Next, we have the fine-tuner. This script trains the TinyLLama model to make games maps. It uses a fine-tune class that manages the whole process. The main function fine-tune model loads the base model and applies method called LoRa to train it more efficiently. If training was stopped earlier, it can continue from the later saved checkpoint. After training, the load map from fine-tuned model function uses the improved model to create a custom map from a simple text prompt. It's clear and organized way to teach a model a new task. The level generator creates games level using strong AI like GPT-4 to build maps based on difficulty and enemy count. If it fails, it uses a small local model TinyLLama. If both fail, after tries, the simple function makes playable map. It ensures a usable map and tracks AI performance. Let's draw our attention towards the main card. The script runs a simple game that uses AI to make new levels. A loading screen shows while an AI creates a map. Once ready, the game builds the levels with walls, enemies, and your character. You play, and after finishing, the AI generates a new level to keep the fun going on. The map shows different example layouts for a game map. Next, we have Model Trainer, which uses a clear method and a clever method, LoRa, to train only a small piece of model, making the process quick and easy. The code starts by loading a TinyLLama model and ready-made dataset. It then logs most of the model's parts so they stay the same and adds a few new changeable layers. Finally, it begins training, helping the model learn its new task without needing a strong computer. Next, we have RPG Intelligent. Uses multiprocessing to run two tasks. The main task runs the game force you to play levels. In the background, another task checks if another gameplay data is collected, then trains the AI to improve level creation. This keeps the game smooth while the AI learns. Next, we have the sample generators. Sample class prepares game maps for training. It formats maps, saves them to a JSON file, checks if there are enough samples to start training, and tracks AI success or failure. Moving on, this defines sprite classes for simple game. It controls how characters and objects look and act. The player class manages movement, animation, and enemy collisions. The enemy class handles enemy movement and random paths. The block, ground, and attack classes cover static objects and short attack animations. These classes work together to make the game world lively and interactive. And dataset.json. This file contains game maps with prompts. Each entry has a prompt describing the level and a map showing its layout. The model learns to turn prompt into maps. Now let's see the demonstration.
It is currently generating the first level, and currently it is calling the TinyLLama model, as you can see here. It calls TinyLLama 5 times, and if the level it's generating is unsatisfactory, then it is going for the ChatGPT. And it is calling for ChatGPT 5 times. And even if it's failing, then it is going for an inbuilt map generator where you are guaranteed to play the map. We play the game without any interference. Currently, it generated a correct map in the second attempt, and we are playing it. And currently, after preset time, which is initially at 60 seconds, it starts training the model with the currently saved data inside the instance dataset. You can see that in the background. The initial training has been completed. Now it starts the training process again after 3 minutes, which is a preset value. We can change the time gap between two consecutive training processes as we like from our pre-intelligent main file. Usually 10 minutes is recommended. However, for demonstration purposes, we are currently running it at 3 minutes. Now the second training process has begun. And even if we close the game, still the training process is not affected and it keeps on working until its process has been finished.
With that, we come to the end of our video. Thank you for joining with us.